Dear students, good evening. Let us continue this lecture series with the next algorithm in floating point multiplication, right? So the next algorithm is floating point multiplication. So suppose there are two numbers floating, so I am explaining this in decimal, right? See, for clarity, for example, I have this two floating point numbers, okay. See, assume that bias is it's already uh, uh, biased, so these exponents are already biased, or okay, okay. See here, so we want to multiply these two floating point numbers. For example, okay, let me assume this is already we want to multiply these two floating point numbers, right? So what to do? We want to multiply these floating point numbers, or okay. So if I do biasing, what I need to do? So while storing, what I do? So I do biasing. For example, let me tell like this. Okay. So this I store as exponent. This I store as mantissa. Similarly, in this case, 925 8 this is a mantissa, 856 is the mantissa. So 6 plus bias, this is what I store, right or not? Now if I want to multiply these two numbers, what I need to do? I need to multiply the mantissas into 0.856 and add the exponents, right? You know this, right? To 10 power 2 plus bias into 10 power 6 plus bias. What to do this? How to tackle this? I need 0.925 into 0.856 into 10 power 2 plus bias plus 6 plus bias, right? But so what I need to do for multiplication of two floating point numbers? I need to just multiply the mantissas and add the exponents. But in the result, what I get? Okay, this is a multiplication result I will get as one mantissa something, and exponent what I get? I get 2 plus 6 is 8 plus bias is 2 bias. But this is the result I will get. But I get 2 times bias, right? But in the result we should have only one bias. So that's why what I do? I need to subtract one bias, 2 plus bias. So once we multiply the mantissas and add the exponents, I need to subtract one bias from the exponent, so that I get back the my original form, 10 power 8 plus bias, right? So this is what the process we are going to do in the, of course, in the binary. So what to do? For multiplying two floating point numbers, I need to multiply the mantissas and add the exponents. After adding the exponents, I will get 2 times bias, so one time I need to subtract the bias, that's it. So these are the points you need to take care in multiplication. So let me directly go for the algorithm. So this is the hardware, same hardware which we are using, so for multiplication, right? Now the thing is, we are, one input is there in the BR, one input is there in the AR, as you can observe here, right? Multiplicand is there in the BR, multiplier is there in the QR, right? So we are using these two registers, right? So one input is there in this register, right? So one input is there in this register, one floating point number, another floating point number is there in this register. But this parallel adder, please note that what I need to do? I need to multiply these two mantissas, right? So what are the mantissas? B and Q. So this P into Q I need to do, and I need to add the exponents, right? B plus Q, right? Now this parallel adder can only add B plus A, right? It cannot add B plus Q. So what I need to do? I need to transfer Q to A, then I need to add the exponents. This is what I need to do, right? So from input Q exponent I need to transfer to A first, then only I can add with the this parallel adder. So that is the reason why first we transfer Q to A, okay. Also see this, the same, this the A1 is the, similarly this also, right? So want to multiply, right? Of course we need to use this adder, right? How to multiply? So assume that these two mantises are fixed point numbers. We have the same algorithm like shift and add method. Using that method we can perform the multiplication, right? For that also I cannot directly do with this with the q, I cannot apply this parallel adder, so I need to transfer this to a, then only I can perform the multiplication of mantises. Using that normal method like same fixed point method I can do that, shift and add method I can do, right? So these are sign magnitude. So you know that sign magnitude multiplication of two mantises can be accomplished by the shift and add method. I already explained the shift and add method. You can follow the same method to multiply the mantises. Okay. Now let us directly go to the algorithm, right? So first step is check for zeros, right? So again, what is check for? So you are trying to multiply these two numbers, BR into QR, right? If BR is 0, result is 0, right? So result you are showing, I told, right? So result is available in the accumulator finally. So just put ASC 0. Even if QR 0 also, the result is 0. So make the result as 0 in these two cases. If this BR equal to 0 is not true, BR not equal to 0 and QR not equal to 0, then only we can start this multiplication process. What is the multiplication process? Just add the exponents, right? So add the exponents. For adding the exponents, what I need to do? So I told that one exponent is there in the one exponent is there in the small q, another exponent is there in the small a, right? Sorry, one exponent is there in the small q, another this is the small q, this related exponent is there in the small b, but I cannot add directly q plus b, so I need to transfer q to a, then only I can add a plus b. So that's why first I transfer q to a, then I perform addition of exponents, right? Then once I add the exponent, one time I need to subtract the bias from the exponent. That's the reason I told, right? Then I can use this multiplication of mantises, right? So this multiplication of mantises I can use the same method, shift and add method, same method, right? You know this method already, I explained in the floating point, in the fixed point algorithm. This is the shift and add method, right? I told, right? You just monitor this qn, the same algorithm you can use for multiplying the mantises, right? Once you multiply the mantises, right? Once you multiply the once you multiply the mantises, there may be possibility that the result is not normalized, right? So maybe the result is there in the A, the MSB is A1. So suppose if A1 is 0, there is a possibility of getting an underflow, right? So for that, how to handle this? Just perform the left shift one time, right? Just perform the left shift one time and decrement the exponent. So if A1 is 1, result is already normalized, you can end the algorithm. But if the A1 is 0, just try to normalize it, normalize the result by performing the left shift. So that's it regarding this multiplication, right? So if they ask in the exam regarding the floating point multiplication, you can explain this algorithm. Also you can explain this multiplication of mantises with the same method, right, as fixed point. So thank you so much.